Hello, and thanks for joining us for this quarter's Climate Service webinar. I am Senior Airman Bogues, and in today's webinar, I'll first provide an overview of the current state of the climate. Next, we will review our two newest climate monitoring and prediction products. Lastly, we will showcase some of our recent tailored products. During today's webinar, if you have any comments or questions, I ask that you please hold them until the end. Questions may be asked over the phone or typed into the DCO window. We will have someone monitoring the DCO Messenger window to answer any questions. Also, please keep your phones muted unless you have a question at the end of the session. Your feedback on the utility of this webinar is also very important to us, so please take some time following today's session to download the 5-question feedback email in the upper left portion of the DCO window or by calling or emailing us. Let us review the state of the climate. If you joined us in October, we showed you a few charts displaying temperature and precipitation trends for the month. This time, we will focus on oscillations that show a teleconnection between the phase they are in and the effects on the climate. A teleconnection refers to the recurring and persistent large-scale patterns of pressure and circulation anomalies that span the globe. The two we will highlight are the North Atlantic Oscillation, or NAO, and the El Niño Southern Oscillation, or ENSO. The NAO is one of the most prominent teleconnection patterns in all seasons. In the positive phase, which occurred for most of December, the NAO tends to be associated with above average temperatures in the eastern United States and across northern Europe. It is also associated with below average temperatures in Greenland, across southern Europe, and the Middle East. The NAO is associated with above average precipitation over northern Europe and Scandinavia in winter, and below average precipitation over southern and central Europe. As the NAO continues in the positive phase, expect temperatures to be warmer than average in Europe and Western Asia, as well as cooler temperatures in Greenland. The NAO is expected to move from a positive phase to a neutral phase for a few days, but will transition back to a positive phase. During that time, we expect conditions to persist as they are currently. The ENSO measures sea surface temperature anomalies across the central and eastern central equatorial Pacific. During El Niño, above normal sea surface temperatures alter the pattern of the tropical rainfall from Indonesia to west coast of South America, which affects the weather patterns across the globe. Currently, the ENSO is in neutral phase, yet slightly positive equatorial sea surface temperature anomalies continue across most of the Pacific Ocean, and there is a 50 to 60% chance to move into El Niño phase over the next 2 months, potentially yielding the anomalous conditions seen here, then returning to neutral conditions thereafter. Since the El Niño is borderline neutral El Niño phase, we have been monitoring some El Niño-like signatures, which we will note in the following slides. As you can see, the NAO brought warmer than average temperatures to Western Asia and Europe, as well as colder temperatures to Greenland. The temperatures in Asia and Europe are expected to stay above average throughout our long-range outlook, or LRO, forecast periods of the next 1 to 6 months. The ENSO, although currently neutral, brought warmer temperatures to the United States and Alaska, which is also expected to persist throughout our long-range forecast periods. Looking at precipitation trends from December, you will see connections between the phases of the NAO and ENSO and the precipitation anomalies. For example, the NAO brought above average precipitation to northwestern and southern Europe. The ENSO brought dry conditions to Madagascar and parts of southern Africa and in northern South America. It also brought wetter than normal conditions in parts of the western United States. The dry conditions in Madagascar are expected to improve throughout our long-range forecast periods. With these precipitation trends, let us take a look at the drought conditions. Drought eased slightly across the globe. Asia saw improved conditions in some areas, especially in central and western part, while India saw a drought decrease. Thailand's drought has cut the rice crop by 30%. In Africa, the drought relief was experienced in the south, while the Central Mediterranean is still drier than normal. North America saw some drought improvement in the west and central parts, while in South America, drought intensified along the southern Andes. Australia's drought continues in the south and eastern parts of the country. Drought conditions are expected to improve over the next 3 months along the west coast of the United States, as well as northern Africa, Elsewhere, expect conditions to persist throughout the next 5 months. If you'd like to see a more detailed forecast for a particular location, please click on the CMAP graphic on our webpage. To reference our Regional Long-Range Outlooks, which is located under the Outlook section, and our Drought Products, which is located under the Drought section. Next, we will go over our newest climate monitoring and prediction products. The first product is the Monthly Situation Report, which is known as the SITREP. This can be found on our webpage under the State of the Climate SITREP. This report covers 23 countries and highlights the state of the climate for temperature and precipitation. To produce this report, forecasters look into flooding, drought, the Vegetation Health Index, news reports, and more to keep planners up to date with the most recent environmental conditions and natural disasters impacting each country and its people. The team also investigates oscillations such as ENSO to determine whether the anomalies affecting the area are related to the current signal. If a region has any significant impacts, they are listed in the highlight section of this report. Beyond the highlights, you will find significant notes to the SITREP to include a drought description table. Below the drought descriptions is our email address, where you may be requested to be added to the monthly email distribution via Nipper or Sipper. The next page is an index of the countries. Each country is hyperlinked and will have a short paragraph describing any drought or flooding conditions, as well as precipitation and temperature anomalies and any impacts. Next month, we will be organizing our monthly SITREP by geographic combatant command instead of country. The next product I will highlight is the snow monitoring reports. Navigate back to the CMAP page and scroll down to the monitoring section. There is a table titled Snow Monitoring Reports. We currently produce snow assessment reports for the Tigris-Euphrates watersheds, the major Afghanistan watersheds, and the major Pakistan watersheds. These bi-weekly regional snow assessment reports are a joint product between the 14th Weather Squadron and the 16th Weather Squadron, as well as the United States Army Corps of Engineers Cold Regions Research and Engineering Laboratory, known as CREL. This past year, CREL began the process of transitioning the product to the Air Force Weather Agency for continued production. With each biweekly iteration, 3 regional PDF reports are produced, providing a high-resolution snow-covered area analysis and a watershed-specific season-to-date total of snow water equivalent, which is used as a measure of snow depth. I am going to show you the current Afghanistan snow report, but each report contains similar information. As you scroll through the report, you will find an overview of the watersheds analyzed in the report and the elevation data throughout each watershed, an overview of the product itself, including data sources and explanations of the variables reported, an expert analysis slide summarizing the conditions seen throughout the report, watershed basin-specific snow-covered area analysis, where you see each watershed boundary identified by a red outline. Snow-covered area is highlighted in blue, and any area with clouds or missing data is highlighted in coral. Basin-specific snow-covered area gain and loss. Here, any loss is highlighted in neon green, and any gain is highlighted in teal. Basin-specific time series plots of snow water equivalent, which include historical statistics provided by CREL. The dashed green line contains the average snow water equivalent. The solid pink line shows last year's snow water equivalent. The solid red line shows this year's snow water equivalent. The dark blue highlighted area contains the maximum and minimum ranges, and the solid teal area shows the standard deviation. The basin-specific information is shown on the next few slides. The last slide contains the observed temperature and precipitation conditions over the full analysis period, broken up by week. Initial distribution of the product began with the list of recipients used by CREL during dissemination. Since our first iteration of the product, numerous recipients have been added to our distribution list by simply sending an email to 14th_WS_SAR@us.af.mil and request to be added to the Snow Report email distribution list. As of 9 January 2015, in addition to our email distribution, the product is available on our NIPR and SIPR websites. Now, Staff Sergeant Brantner will highlight some recent climate support requests.
Hello, I'm Staff Sergeant Brantner, and I'd like to start by discussing climatology in data-sparse regions. This map depicts the sources of weather data ingested at the 14th Weather Squadron in a single day, with white dots representing individual locations. As you can see, areas like the United States and Central Europe have a large number of sites reporting weather data. However, other regions have significant gaps. Providing climatology support for deployment hotspots like the Middle East, the Horn of Africa, and South America is particularly challenging due to a lack of reliable data. Fortunately, we do have options available to provide support in these data-sparse regions. The next two examples of recent support requests illustrate our capabilities in these situations. One of our newest options for providing support in data-sparse regions is the Temps Precip Trends product. This product was initially created to fulfill requests from the intelligence community and is based on NOAA's Climate Forecast System Reanalysis, or CFSR, global gridded dataset. Rather than producing these trends plots as needed, we have rolled out a Google Earth KMZ file which makes them available directly from our website. Regardless of the availability of observed weather data, we can now provide a good estimate of temperature and precipitation normals, as well as the past year's and current year's trends for over 17,000 points around the world. Next, a user from the AFCENT KAOC requested climatology data for Bushehr Airfield, Iraq. The AFCENT Director of Mobility Forces was evaluating locations for potential use in temporary airlift operations. Unfortunately, our standard products were not available due to a lack of weather data. Once again, using data derived from NOAA's CFSR Global Gridded Dataset, we were able to provide temp precip trends as well as windrows products for the location. Additionally, we used a spatial climatology-based process to create a pseudo-OCDS that includes data for several weather parameters. Using these products together provides a good overall estimate of climate conditions for a location. Moving away from climatology in data-sparse regions, the next example is a request from a user at AFIT that requested severe weather data for CONUS Air Force bases. This user was studying the cost impacts associated with severe weather. We created these plots of tornado tracks, hail, and damaging winds over the past 20 years based on the National Climatic Data Center's Storm Events database. In total, we provided the user with data for 72 different locations in both image and text formats for use in his study. Lastly, the next user requested lightning climatology for the Western Pacific region. The user needed a 5-year average climatology for the region, as well as data for 2014, in order to compare the current year to the 5-year average. The top image depicts the mean number of thunderstorm hours per day over the past 5 years. The bottom image depicts the anomaly, or deviation from the 5-year average depicted in the top image. Using these images together, average expected thunderstorm conditions can be assessed while also comparing the current year's thunderstorm activity with the average. This information was integrated into an operations assessment for Global Hawk missions provided to the PACAF commander. These are just a few examples of what our climate analysis team can do to provide you with what data you need. An important thing to keep in mind is that we generally can help you better if we have as much information as possible and we know what you are trying to do. We look forward to hearing from you. This concludes this quarter's webinar. Please take a moment to provide us your feedback on this webinar as we look forward to incorporating your inputs into future webinars. At this time, we'd like to open up the floor for any questions or comments.